looking at is the types of atoms, and to start looking at names of different species. And as you can tell, this is kind of difficult because I can lecture. You really don't get a chance to ask questions. So please make sure you check the notes and figure out ways to contact me and look for different sessions that we put up for reviewing. All right, types of species. When we talk about types of species, you look at the periodic table and you say, oh, it's just an element. Yes and no. Some atoms are elements are atomic. That means they consist of one atom. Okay, one single atom. So things like silver, potassium, nickel, you can get one atom of. However, some elements are what they call molecular. That means that they are two or more identical atoms combined. So, two weirdos are P4 and S8. You don't find phosphorus as a single atom. You tend to find it in the form of P4, four atoms together. That's its natural elemental state. Sulfur, there's actually a second one, which is S2, but S8 is a very common one. But some of them exist only as two atoms together, which are diatomics. And these you need to know. These are the ones that have two atoms combined. And you can do this a variety of ways. The species are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Now, there are a couple ways to remember these. I put hydrogen over nitrogen and walk it around. But two mnemonics are I bring clay for our new house, or horses need oats for clear brown eyes. This is ways you can remember the diatomics. And the reason why it's important for these molecular elements is that is considered their elemental state. That's their normal. Okay, so you don't find oxygen as a single oxygen atom. You always find it as a diatomic, which is why when they talk about breathing, they talk about O2, not O. Okay? Compounds, remember, are a combination of two or more different atoms. Different, if I could, again, spelling optional. Different kinds of atoms. Guys, I'm doing my best. This is way easier in person than it is online. Okay? So there are two different types, which is ionic, which means you have positive and negative ions combined to form ionic bonds. They form ionic compounds. We've gone over that. Molecular, the electrons are shared to form compounds. And remember when we did this, these usually involve a metal plus a non-metal, whereas these are all non-metals. Okay, metals are M, non-metals are NM. I don't know where that came from. Okay, so this is the first type of differentiation when we look at a periodic table. And this one's highlighted, as I said, I put the hydrogen over the nitrogen and then it makes a 7. There are 7 of them. Yeah, whatever way you can remember them. I told you to worry about phosphorus and sulfur. I didn't tell you to worry about selenium, so you're not responsible for that one. But these are your molecular elements, and this is not on the periodic table I give you, so you just need to go ahead and memorize them. That brings us to nomenclature. And when you're naming, some things are simple because you know what they are. For example, if I were to ask you right now, what element is H, you'd say hydrogen. C is carbon, oxygen. Magnesium is Mg, which is different than manganese, which is Mn. Aluminum is Al. Nitrogen, phosphorus, sulfur, chlorine, Cl. Calcium, Ca. Those are pretty obvious. Now, some of the other ones that are very commonly used, not so much. So antimony is obviously has the symbol Sb. What? Well, that's because it's based upon old nomenclature. And the reason why I'm going through these is you need to know them. And if you're like me, it's easier to remember something if you know why it's weird. So I like to go through these things. Antimony, the original name for it was stibium, which is where we get Sb. Copper, Co, is cobalt, but copper is cuprum, so that's Cu. Gold is aurum, Au. Iron is ferrum, which is Fe. And we'll actually get to that. If you've ever had to take iron tablets, you may have seen a bottle where it refers to them as ferrous sulfate. You, Iron is one of those things you actually see on a regular basis as the ferrum. So that one's not so bad. Lead is obviously Pb. And actually, this one makes really good sense because lead is easily melted and formed into different things. That was the original guns. Shells was lead because you can heat it and it melts at a low temperature. But because of that, the Romans were able to use it to make piping so that you could bring in water to your house. We call that plumbing. So that's why plumbing or lead is plumbum, because it was used to make water flow into people's houses. Okay, the side note on that one is that if you get lead in your diet, it makes you crazy. Hence, again, the fall of the Roman Empire. Okay, I'm gonna skip mercury and come back to it. Potassium is kalium. Sodium is natrium, and P is for phosphorus. Potassium is K, and natrium is sodium. These were actually the old nomenclature. They were named after old planets or stars. So, but they're really common, like sodium chloride. So you need to know that sodium is Na, and it's because they come from the planets. Now, the one I skipped over is silver, which is argentum, which is Ag. Gold is Au, silver is Ag. If you've ever heard the phrase quicksilver, okay, that's mercury. If somebody is talking about quicksilver, they're talking about mercury. It's a liquid. So it looks like liquid silver. So that's why if you look at this is hydroargyrum, which is hydra is liquid, silver. So that's why mercury is Hg, hydroargyrum. Okay? Comes from that one. Tin is under lead. That comes from stannum. And I did tin previously when I was doing the formulas. And the formula for tin is Sn because it comes from stannum. Now, this one I just like to say out loud, so you're responsible for it, is tungsten. Has the symbol W because the old name for tungsten was wolfram. Wolfram works for me, so I'm not really sure why they changed it. Of course, I'm not asked for this. So, therefore, you need to start memorizing a lot of these species. Now, which ones are you responsible for? Okay, Like, I don't even know what SM is. Okay, samarium. But I don't expect you to know things that we don't talk about and we go over. As we work problems, we're going to address different elements in naming and oxidation numbers, etc. If you've seen it a variety of times, then it's fair game, like tungsten, fair game. Any of these on this list are pretty much fair game because I've taken the time to go over them. And the reason why I go over these ones in particular is because they're used heavily. Okay? So you might want to start learning them. And in the summer, your time is truncated, so you might want to start sooner rather than later. Now, some of them, and these are mostly within the transition metals, will have variable oxidation states. And if you'll notice, some of them have different names that go with them. The four, and there's a later slide, but I'm going to go ahead and tell you right now, you're going to be responsible for the naming on those, not the rest of them. But when you have different oxidation states, you're going to have to name them differently. And I said two words that we haven't done. We haven't done oxidation states, and we haven't done nomenclature. Now, I'm going to tell you right now that the oxidation numbers are done in chapter 3 or 4, and you're like, wait, we're in chapter 2. That's true, but there's a reason for that. It's because of nomenclature, and in the next section, I'm going to go over oxidation number rules because you need that for the next section, which is naming. So right now, we're just going to start learning the elements